Hello everyone, hope you're having a great day. In today's video, I'm going to show you how to make involute gear tooth profile using equations and law. To do that, first we are going to make sure that we can access formulas and relations that we are going to create from the specification tree. To do that, go to Tools, Options, Infrastructure and Part Infrastructure. Under display tab you need to check these three options, that is constraints, parameters and relations, so that you can have an accessible pair of relations and parameters from specification tree. Click OK. Now we're going to enter into shape and generative shape design. The first thing that we're going to do is to create the parameters that will require to make the gear tooth profile. First will be the module. To create parameters, you must know where is the knowledge toolbar. If you don't have knowledge toolbar, you can just right click and click on knowledge toolbar, or you can go to tools and click on formula. So click on formula option. The first parameter that we are going to create is the module that we have taken with 2 mm, so obviously of length data type, length, new parameter of type, change its name to m and give it value of 2 mm. Click on apply. As you can see, the first parameter has been created. Similarly we are going to create more parameters that will help in creating the involute gear tooth profile. The next will be the number of teeth, which will be of real type. We cannot select the integer type, as the integer type can also take a value in negative. So we are going to select real type and change its name to Z20. That means that we are going to create a gear which have 20 number of teeth. Next will be the pressure angle, which will be of angle type, and name it A, give it value of 20 degree, click apply. So these are the three basic parameters that will be required in creating the gear tooth profile. Next up will be the pitch circle radius, which will be of length type RP. Now we are going to add a formula for the pitch circle radius. Click on add formula. The formula for pitch circle radius is module times number of teeth over 2. Click on OK. As you can see, the formula that we have entered generated a value for the pitch circle radius. Next up will be the base circle radius RB. Click on add formula. The formula for RB is RP times cosine of pressure angle. So RP is calculated. Next is the radius of addendum circle, that is RA. Add formula RP plus M. Here M is actually the value of addendum. Again RD, add formula which is the dedendum circle radius RP minus 1.25 times module. Click on OK. So now that we have created the basic parameters required, we are going to stop here for now and start creating the gear. First we are going to create the addendum circle. To do that, go to circle, for creation of circle we need a center point, so we are going to create a point first on a plane. Select this plane, that is the front plane or YZ plane. The point will be at origin. Click OK. Now this is the point that we are going to take in and as a reference for every circle that we are going to make. First circle will be addendum circle. For center, click on this point. Support will be the same plane and the radius will be the addendum circle radius, that is RA. Double click it, click OK, OK again. In front view we can see the addendum circle has been created. Now that we have created the addendum circle, we are going to extrude it into part modeling. Just click this profile and select pad option. 10 mm is the value that I am going to take to extrude it. Preview. and OK. You can see we have extruded the addendum circle. Next up, we are going to hide it. Again, we are going to enter into generative shape design and create two equations that will make the involute curve. As you know, the involute curve have two equations that is displayed right now. Now that we know the two equations, we are going to create these equations in the knowledge toolbar. Near the design table, you see another option that is FOG icon, which is actually the law option. Click on it. Now the law editor has been displayed, in which we are going to name it x, which will be the x equation. Click OK. In this empty space we are going to enter the equation for x, but first we are going to create two parameters. The first one will be x, which will be the output in length type, and the second will be of the real type, which is t, in which is the independent variable which we are going to change it. First will be of length, change its name to x. Second will be of real type, change its name to t. Now that we have created two parameters, we are going to enter the equation. As you have already seen the equation, I'm just gonna copy and paste from my notepad. Copy, paste, click, apply, and OK. Again, we are going to do the same thing for y. Change its name to y. OK. Real type of t, name it t, and again length type will be y. Again, I'm just gonna copy and paste from my notepad. Copy, paste, and apply, and OK. Now that we have created two equations, we are going to create the points that will eventually make the curve. To do that, go to select the point option, just double click it, as we are going to create 6 points that will make the curve. Double clicking it on plane. Plane will be the front plane, obviously. Just a quick tip that the plane we have selected will be the same plane in which we have created the origin point, the circle, and all the circles that we are going to create in the further steps. Here h will be the x coordinate and v will be the y coordinate. For h, just right click, edit formula. Here just expand the relations tab, double click the FOGX, which will be resulting in the appearance of this relation /x backspace dot evaluate for 0. The 0 is the value given to the t, which is of real type. Click OK. Do you want this relation to be updated when global update is performed? Select yes. For v, just double click on y, backspace dot evaluate for 0. Click OK, OK again, and OK, OK. Again the point definition has been appeared, so we are going to repeat this step 5 more times so that we can enter the value of t from 0 to 0.5, which will eventually be resulting in the creation of 6 points. So I'm just gonna fast forward this Now as you can see, I have created the 6 points that we need. These are the 6 points that will eventually make the involute curve, and you can see the equations that I have used to change the value of t from 0 to 0.5. So now we are going to make the curve using the spline option. You need to select the points in the same order in which they have created: first, second, third, fourth, fifth, and the last one. As you can see, we have created this spline. We don't need these points, so just hide them for a better view. Okay, let's just hide this point too. Now we are going to create the dedendum circle. For center, select the first point. The support will be the front plane. The radius will be RD, which is just double click RD and click OK. As you can see, there is a little gap between this point, the first point, and the circumference of the circle, which is due to the fact that the involute profile of the gear tooth starts from the base circle, which lies on this point. Now there's quite a difference between the base circle radius and the dedendum circle radius, so what we need to do is to extrapolate this spline so that it can intersect the circumference of the dedendum circle. Click on extrapolate. The boundary will be the first point. The extrapolator will be the spline, and the length will be the formula RB minus RD times 1.5. The constant 1.5 is just to make sure that the spline that we are going to extrapolate intersects and exceeds the circumference of the dedendum circle. Now press OK. The next thing we are going to do is to add fillet at the foot of the tooth. This is the foot of the tooth, and here will be the fillet. To add the fillet, go to just corner, select the first element, which is the extrapolated spline. The second will be the circumference of the dedendum circle, and the radius will be calculated using the formula 0.38 times of module. Click OK. The radius of the fillet is calculated as 0.76 mm and click OK. Before click OK, just check the trim element 1 so that you don't need the extra spline that intersects the circumference of the circle. Click preview and OK. Now that we have created the involute profile, we are going to do the mirror of this profile about a plane that we are going to create. To create a plane, we need to define two more parameters that will define the angle about which the plane will be rotated. So the two angle will be as here displayed. To create those two angle, again click formula, select angle, change its name to A, add change its name to C, add formula. Just I'm going to copy from my notepad, copy, paste. You can see the value of C has been calculated as 0.854 degrees. Again we are going to add another parameter naming phi, adding formula from my notepad again, copy, paste. OK. 3.646 degrees is the calculated value of phi about which the new plane that we're going to create will be rotated. So click on plane. You must select the angle / normal to plane. The rotation axis will be x-axis. The reference plane will be the zx plane or the side plane, and the angle will be entered using formula which is phi. Click OK. So now that you can see the plane has been created, which we cannot see here, as 3.646 degrees is a very small amount. Now that we have created the plane, next step is to mirror this profile. So go to symmetry option, click element, the curve, and select the reference plane from tree. Click OK. Next up is the creation of addendum circle again. Because this creation is due to the fact that we don't require the extra curve that lies beyond the addendum circle, so that we can trim the extra curve. To do that, go to circle again, click the center, support will be the front plane, radius will be RA from the formula. Click OK. This extra from here to here, this is the extra curve that we don't require. First we are going to join these two using the spline option by clicking these 2 points. Click OK. Now actually joining these 3 elements, 1, 2 and the spline. Click OK. If you don't join these 3 elements, the trimming won't be happening, and it will give an error. So click on trim, select these 2 elements, and you must adjust according to the result you want. So we have created this profile, and now we don't need the dedendum circle. Next thing what we are going to do is to circular pattern this profile. To do that, click on profile, insert, advanced replication tool, circular pattern. The instances will be the number of teeth, which is Z. Oh, I must double click it. Okay. Select complete crown option. Reference element will be x-axis. Click preview and OK. Now that we have created a circular pattern, the next thing will be the joining of the parent profile and the circular pattern. You must uncheck this connexity. Click OK. Now just unhide the pad or extruded part and go to part modeling. Just extrude cut the circular pattern that we have created from the extruded pad. This pocket, reverse direction up to last, preview and OK. As you can see, we have created a gear which have 20 number of teeth and a module of 2 mm and 20 degree pressure angle. Here are the parameters. Now since this is a template of gear, we can change these parameters that we have, these 3 parameters, by let's just take module of 3. Okay, the gear is now created with module of 3, number of teeth 20 and pressure angle 20 degree. Now we are going to change the number of teeth to 30. Okay, this is the gear of 30 number of teeth, module 3 mm and pressure angle of 20 degree. What if I enter a value of 42? Obviously it will give an error because 41 number of teeth is the maximum value of number of teeth that a gear can have with a pressure angle of 20 degree. So if we want a gear of teeth with a higher number of teeth, that let's just say more than 41, you must change pressure angle to 14.5. So for a pressure angle of 14.5, the number of teeth that the gear can have, that is the maximum number, which is 78, I think. So that will be pretty much, let's just change its value again to 40. So you can see 40 number of teeth can be created. So Here's the template of Spur Gear having involute gear tooth profile. Thank you for watching. Have a nice day.